So let's take a look at these questions. Question number 10. A and B are mutually exclusive events. If PA is 0.42 and PA or B is 0.79, calculate PB. So for mutually exclusive events, remember the probability of A and B is equal to 0. So for 10.1, we can use the formula P, A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Now A and B is 0. So probability of B here, then plus probability of A, we got 0.42. And probability of A or B is 0.79. And so we can see the only unknown is PB. So probability of B is equal to 0.79 minus 0.42, giving us 0.37. Okay, let's move on. Question 10.2. A game at a fun park requires a player to roll a 6-sided dice and pick up a card from a deck of 52 cards. Okay, a player wins if an odd number appears on the uppermost face of the dice and the player also draws a picture from the deck. Okay, so to win, two things need to happen. You must have an odd number on the dice and you need to have a picture card. A deck of cards has 4 suites: hearts, diamonds, spades, and clubs, and there are 4 picture cards: king, queen, jack, ace in every suite. A player pays 10 Rand to play a game, and in an hour, 260 people can each play one game. If the owner wants to make a 70% profit per hour, calculate the maximum amount that the owner must pay out to each winner. Okay, so first thing I want to do is I want to figure out what is the probability that you win from rolling a dice, and then what is the probability that you win from just selecting a card or drawing a card from a deck. So for the probability for the dice is going to be the number of odd numbers divided by the number of sides. So on a dice, a 6-sided dice, there are 3 odd numbers and divided by 6 sides on the dice, so that's half. And then if you look at the deck of cards, so the probability for the cards, there's 4 suites and 4 picture cards. So 4 times 4 is 16. So there are 16 cards that you could win, that would result in you winning if you picked it. So 16 divided by 52. That's the number of cards in the deck. Now the probability of both of these things happening for you to win. And remember, they are they're independent of each other. So the probability of you winning is going to be 16 over 52 times half. And that's giving you 16 over 104. So that's the probability of you winning. Okay? Now, you could also think of it like this. Out of 104 people that play, 16 would win. So if in that 1 hour, 260 people would play, what I'm interested in is trying to figure out how many would win if 260 played. So to do that, I'm going to say 260 divided by 104 times 16. So let's put that. So 260 divided by 104 times 16. So 40. So 40 out of 260 people would win. Okay. We're not done yet. So now we need to focus on the money aspect. So there's 260 people who's going to enter and 40 would win. So if 260 people are paying 10 Rand each, that means the total income or the total revenue for this person that's running this this game is going to be, so the revenue is going to be 260 times 10, because it's 10 Rand per game. So that's 2,600 Rand. Okay, so 2,600 Rand is the amount that that person would get. Now we need to focus on the profit part. So we can think of it like this. The revenue that the person gets needs to be split up into two avenues. One avenue is going to be the cost, right? You could think of it as the payout. So this is the payout to the 40 people, right? To the winners. And the other aspect is going to be the profit. So from the total revenue, some of the money is going to be cost. So you're giving that to some of the winners. And then the other part is going to be the profit that he wants to keep. Now, you can keep, let's say that the cost, let's call the cost X, right? We don't know how much the cost is going to be. And the profit is going to be 70% off that. So 0.7x. So we know that the revenue, which is 2,600, is going to equal the payout plus the profit. So x plus 0.7x is 1.7x, and that's equal to 2,600. That means x is equal to, let's check, 1529.41. Now remember, this is the payout to the 40 people, right? That's the payout to the 40 people. So each person would then get 1529 divided by 40, which is 38.24 rands per person. Okay, and that's it. Let's move on to question number 11 now. So question number 11 says, consider 3-digit numbers from 501 up to 999. How many of these 3-digit numbers have exactly 15 in them? Okay, so let's figure out the total number of numbers first. So the total number of numbers from 501 to 999, we'll say 999 minus 501 plus 1. That's equal to 499 numbers. So there are 499 numbers in total. And we're going to need this just now. Now, if we're looking at these numbers, right, we have to look at the hundreds, the 100 digit. We'll need to look at, or the hundreds place, the tens, and then the units. So if we're starting with the hundreds unit, right? So 5, there has to be a 5 there, right? So we're starting with the hundreds, then the tens, then the units. Now, if we're starting from 501, how many possible numbers could go in these tens units? In the tens, I could have a 0, I could have a 1, I could have a 2, a 3, a 4. I can't have a 5 because remember the whole number must have only one 5. I could have 6, I could have 7, I could have 8, I could have 9. So in total, I could have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So there's 9 numbers that could fit there. And likewise, in the units, I can have the same 9 numbers. So I have a total of 9 numbers there. So in total, I'll have 81. So 9 times 9, I will have 81 different numbers that are going to be from 501 to 999 that have a 5 in the hundreds unit only. Okay? Now let's look at the tens. So here I can have some number. The tens has to be a 5, and then the units can be some number. So what numbers can go in the hundreds? What numbers can go in the units? So in the hundreds, I can't have a 5. I can have a 6, I can have a 7, 8, or a 9. So I can have 4 total numbers here. In the units, I can have the same 9 that I had there. So 9 here. So 9 times 4, 36. And then lastly, let's do the units. So the units must have a 5. This can be anything. This can be anything. So what numbers can I have here? I can have a 6, I can have a 7, I can have an 8, I can have a 9. And in here, I can have any number from 0 to 9 except 5. So I can have 9 numbers there. So there's 4 here and there's 9 here. 9 times 4 is 36. So how many numbers in total will have exactly 1 5 in them? It's going to be 81 plus 36 plus 36, which is equal to 153. And then moving on to the last question, calculate the probability of a 3-digit number not satisfying the condition. So if 153 out of 499 satisfy the condition, that means 346. So 499 minus 153 is 346. 346 out of 499 do not have exactly 1 5 in them. Okay, that's it. Thanks everyone. Thanks for watching. Don't forget to like, share, and subscribe. I'll see you in the next video. Bye-bye.